Okay, good morning, everyone. I think that we can get started for this morning. As I was walking over here, there was a woman standing in the hallway looking at the basketball courts, and she said, "Are you going in? Because it's more interesting than to being here than being in the sessions." So I will set the bar there. I hope that it's more interesting to be here than in the hallway. So today we are going to talk about the drive selection process for power mobility users. I have seen a lot of you over the past few days on our booths, so probably you're aware that I work for Movis. We're a very small Belgian company where we make special controls for powered wheelchairs. About half of us are engineers. I'm not. If you're going to ask an engineer to do a presentation here, they would probably stop at hello, especially when they see all these women in the room. So it was not very hard to decide that I would have to do the presentation. All photos and videos have been used with user permission, and you can find a handout in the resource center. I want to start with a video of Steven, a 30-something Belgian man with Duchenne muscular dystrophy, who is using a very sensitive joystick for the first time in his tryouts. And this is the first time that he's using it. Oh, why is it doing that? Okay. If anyone knows how to solve that. Yeah. In which modes? Yeah. Was that it? Yeah. I hope it's not for all the videos, so. Yeah, so he's driving for the first time. Maybe I would just explain it with a micro joystick integrated in his tray, and he can do it really well. But up until that time, he was using a standard hand joystick, which which is 250 grams of force, which was quite impressive for him to still be able to do that. But he couldn't control it anymore. So they swapped it with a joystick of 8 grams of force, whereas this one, turn it on. Whereas this one is 250 grams of force with a travel of 20 millimeters. That one is only a travel of 3 millimeters. So he manages quite well, but they didn't try anything in between the 250 grams and the 8 grams of force. So a lot of people know the standard joysticks, the mini joysticks, the heavy duty joysticks, but not the options in between. So for today, we're going to look at options for when the person cannot reach the control or cannot operate the control, and what you can do to improve on efficiency or safety for the end user. So some clinical background: around 10% of the power wheelchair users need individualized adaptations to their seating, to their power mobility system to be able to do daily activities in life. And it can have a big impact on their quality of life. The other 90% are using traditional hand joysticks like, Arna joysticks, linked joysticks, Curtis electronic joysticks, or standalone hand joysticks without a display. Of the 10% of the people who need individualized adaptations to their control system, half of them also need other specialized seating or tilt-in space. The people who would need it are people with neurological or neuromuscular diseases, such as people with Duchenne, ALS, muscular dystrophies, other muscular dystrophies, cerebral palsy, and so on. So the question of today: what if they cannot use that standard hand control? How will you select an alternative? So what is needed to control a power wheelchair? First thing is, we propose a framework to formalize that a little bit. So the first thing is purpose. What is the situation today, and what can the person not do with that control? What would he like to do with an alternative? The second is cognition. What are the cognitive possibilities of the user, and how does that link into a type of control that they would use? Next is approach. Can you see the control? Are you stable enough? Can we get the control to the user? Then we have operation. Do you have enough strength to operate that control? Or do we have to do some other programming to help you with that? And then finally, we have learning. Can the user operate that control right away, or is there a learning curve? Do you have to help them? How can we follow up on that? How can we assess if they are indeed getting better at it? And this is often an iterative process that you will have to go through several times, especially with degenerative diseases, and each stage can also reveal new aspects. Finally, to check if you are achieving those goals, then we can look at ways to measure the outcomes. So first, purpose. What is the intention or the motivation to look for a new control? The benefits of power mobility are, of course, widely known, and it enhances quality of life. But studies show that 40% of the power wheelchair users have problems with executing the basic tasks such as rolling forwards, maneuvering, and this is often due to a lack of fits between the equipment that they are using and what they can do. So the motivation might be that the user wants to be able to do these basic tasks like rolling forward or backward, turning, maneuvering, parking, but it can also be things that are not really drive related, such as turning the controller on and off, operating your speeds, changing your seating positions. It might also be not related to anything of the wheelchair, but engaging in social activities, which then in its turn also has its own benefits. This is also a good moment to mention the Wheelchair Skills Program for the first time, which is a set of free assessment and training protocols that is quite known, right? But it is still highly underutilized. And at the start of the selection process, the skills of the user should be assessed. It's very important to do that, otherwise you cannot measure the outcomes afterwards. So the WSP can help you in deciding what the purpose of the new control would be. So during the assessment, prior to the training, it would be good to ask the user, what do you want to do with the new control? What is the purpose? What would you like to do better? And the WSP has an activities and participation checklist that can help you in deciding these goals. The goal may be a full skill or a part of the skill or any other skill that is important to the life of the user. And during assessment, it has to be decided whether the goal is feasible for the person, and that is sometimes a judgment call, right? It's a judgment call. But when in doubt, we should let the learner try. So next video, hopefully everything goes well. So this is Nathan, a Belgian teenage boy with cerebral palsy, who was denied an electric wheelchair during a previous assessment with a standard joystick. So no. So he has spastic movements, so a standard hand joystick was not the right fit for him. His big movements would result in unwanted movements of the wheelchair, or he would damage the equipment. So he had no means at the moment for independent mobility, and he has to rely on an attendant to bring him everywhere. Okay, that's annoying, but... so what they did a modification of the standard joystick. They placed a heavy-duty version on it. So the standard one is 250 grams of force, and they replaced it with a heavy-duty one of 650 grams. So instead of 250 grams, 650 grams, and a travel of 40 millimeters. So that's a very big difference. And it's more difficult to break that joystick or rip it off. The video will be sideways, of course. But if you could see it, then you can see that he manages somewhat to drive. It's his first time, of course, so he will need a lot of training, but it will mean a world of difference to him that he can drive, even if it's a little bit. So that's great, and that's something that he will now use. So when you have decided the purpose of the alternative drive control, then you can assess the person's cognitive abilities. And the cognitive abilities are important to decide whether the user might best use a proportional or a non-proportional control. Proportional controls are always a preferred input method whenever possible, and they work like a gas pedal in a car. So the further you move the joystick away from the center position, the faster the wheelchair will move. Most common proportional control is a hand joystick, but there is a wide variety of alternatives available. A proportional control can be placed anywhere as long as the user has access to at least 180 degrees of movement, 3 directions of movement, or ideally 360 degrees of movement. Using a proportional control, however, requires some cognitive skills, as you have to be able to grasp the concept of it's going faster when I push more. You have to understand cause and effects, spatial relationships, and so on. Individuals who do not have the capabilities to drive a proportional control also have a lot of non-proportional or digital possibilities where they're driving with a switch that is on or off in 4 or sometimes 8 directions of movement. You have to know that there's also a wide variety available there, but I will focus today on the proportional controls. When you have a good sense of the purpose and the cognition, you can then go on to assess the approach. In other words, how will you get to the control? I have already mentioned that optimal seating is key, and this is linked to it. You need a core stability. It means the ability to maintain a stable and a balanced position in your chair. And you can work your way up from your pelvis to your lower back, higher back, and so on. You can see maybe you need a positioning cushion, maybe you need lateral supports to have a good stability in the chair. This way, the shoulder joint, for example, which you would need to go to a hand joystick is a lot more stable. When you think about it, if you're sitting not straight and you want to reach even just a glass of water, it's more difficult to do that. And then, it's a fitting quote, I guess. So power mobility systems are intended to provide function and mobility, and without stability, there can be no function. So this should be one of the first things you do. And then I don't know if any of you were in the session about a multi-segmented approach to head supports by Bart van der Heijden and Felipe. But they also mentioned that for head supports, you have to work your way up from the pelvic area all the way to the head. So you start low, you go back to the head. And this can help you to get your head to have an ideal line of sight. Ideally, you need vision to be able to find your control and to safely navigate your surroundings, see where you want to go, judge distances. If you are having a hand control, ideally, you want to be able to move your visual field to that hand control. The 10 to 15 degrees above the horizontal field is what we call an analytical visual field. And you want to try to get things there. Besides that, you only see colors and movements, so you want to try to focus on the control. That means that driving with a foot control, for example, is more difficult or sometimes impossible. The learning process is also bigger as you cannot visualize and see it. And of course, some of you are thinking now, well, wait a minute, I know a person who is blind and he's driving a power wheelchair. Yes, of course, that's possible. But ideally, if the person has vision, you should do everything to have good head support, good vision. We also know of someone who is driving blind in his apartment, so it is possible. You also need muscle function to approach the control, any control, whether it's a hand control or not, or for a hand control, the ability to flex your shoulder and extend your wrist and elbow. And if you can, it's quite simple, but if you list all the different muscles that you need to do that, you see that it's not such an easy task. So clients who cannot reach these, who cannot control these muscle groups might need an alternative control. It's not only getting to the control, it's also being able to let it go. So if we go back to the example of Nathan, for instance, it's not a video, so no problems there. Then you see that they have added a positioning vest to his setup so that he has better core stability and also better fine motor skills. The dysfunction of the muscles group is resolved in a big way. So now it's easier for him to get to the control. And an assessment of the muscle function is always needed. The list that we saw in the previous slide is for the hand control, but perhaps that's not the best location for your client. And you also must have a repeatable upper extremity control for that, and not just at the moment of the assessment. So you need to find out which body parts allow for the best motor control. The interaction between the user and the power chair involves relatively fine control, and the hand and the fingers are, of course, the preferred anatomical side to do that, as you have best fine motor skills there. And you can have a hand joystick at a distal position or more at a medial position. But if the fine motor control limitations do not allow you to do that with your hands or your fingers, you can look at the head, because it's probable that you will have good control there as well, or you can have tilting side to side or forward, backward. And with the head, it's not only the back of the head, it can also be the chin, the lip, the tongue, anything that is possible for the user. Another possible control side that is used less frequently is a foot control. There's no visual monitoring, as we have said, and it's generally not as finely controlled as the hands or the fingers, but some individuals can have good control there. And that's usually how it goes. We start with the hands and the fingers, and if it works, fine, we take that. It's the simplest solution available. If not, we go and find the next simplest solution. But sometimes it's also worth thinking about other options. It's a pity that this video will be like that as well. But this is Sophie, a Dutch girl who has a very rare case of Ehlers-Danlos syndrome. And she has been driving a micro joystick for over 10 years, integrated in a medial position in her tray. And nobody ever thought of any other control, right? They started with the hands, the fingers, it worked, so they stopped. But she actually had quite good control in her legs and in her foot. And she was at our office and she saw foot control and she said, "Can I try that?" So we placed it under her foot and she managed to control the pedal. And then we did a quick installation on her chair. Yeah, it's like that, and you can see that it's very easy for her to drive it right away. So this is the first time that she's using it. She was driving really fast in our warehouse. We were a little bit scared for her. But it was, excuse the word, but it was a mindfuck for her to know that after 10 years of driving only with her fingers, she could now use another body part to do that. And she will probably stick with her micro joystick for now, as she has a tray where she has a second small joystick to control her robotic arm. So she needs a tray anyway. But she also likes to play wheelchair hockey. And it's an option that she's considering to do there because she doesn't need her tray there. Sophie is an advocate for more knowledge about what's possible with assistive devices, especially robotic arms. So she asked me to give her a shout out. There's her Instagram and YouTube channel if you would like to follow her. But let's go back to the hands. Even if the hand function is limited, the remote can accommodate for the limitations in fine motor control through adaptations of the handles. A different shape of the handle means that you will need different muscles, different flexors and extensors to control that. A pinching movement, for instance, can be way more difficult than just pushing to another handle. For that joystick, for instance, we have 3 different handles, but some people even use it without a topper, just pushing to the small stick. And yeah, there's a lot of other options available, of course. With progressive diseases, it's also good to take that into account right away. How do we expect that it will evolve, and can we search for another topper that allows the person to use that? It's also very important to make sure that the hands and the fingers, in this case, are very well supported. We have an example here of Torsten, who has congenital multiple joint stiffness and nerve damage, and he cannot move his fingers separately from one another. And not only have they replaced the standard handle like we have seen with Nathan, with a heavy-duty one, they have also made him a custom mold. So now he can drive just like this. He doesn't have to separate his fingers, and he can still do what he loves to do. So many other options are possible, of course, and with the rise of 3D printing, we see that's happening more and more often, and that's a good thing. To have the control at an optimal position for the user, you have to be able to place it there. For the hand control, most wheelchair manufacturers allow for some adaptations, like placing the standard control in a table with or without the option to swing it away. And some people are really in favor of doing it in the medial position, especially people, for instance, with Duchenne muscular dystrophy. It can be a lot more easy to drive in the middle position. You can also use the standard hand joystick and integrate it without a display. Then maybe you want to have some other kind of visual feedback for that. For other joysticks used with the hand or the fingers, custom solutions might be required, such as dedicated mounting brackets by some manufacturers, like we see here, to mount it in a tray. Or sometimes the dealer might need to make a special modification. A micro joystick integrated in a tray, and you can just swing it away like that. Some people have some control over their fingers and hands, but encounter problems when the fingers get cold or the hands get cold and stiff. And the already very reduced movement capabilities become even more difficult or even impossible. And a hand warmer, for instance, can help in that case as it blows warm air on the fingers. So the finger flexibility is maintained. So this is correct. A micro joystick integrated in the tray here. He's just using his thumb to move it. And the hand warmer is placed some 10 centimeters away from his fingers so that he can retain the flexibility. I know that it's probably less used in the United States than in some countries in Europe. Belgium is not that cold of a country, but we have people with Duchenne who are using this the whole year round, indoors always without a dome. And when they're going outdoors, they're using a dome, like Hendrik. It's a German boy with Duchenne. He has the micro joystick that he's controlling with this finger. He has a switch that he can control with this finger. And then they have put a dome on top of it, and they have mounted the hand warmer in the dome. And his father also did that. So it's blowing warm air on his fingers all the time. They have also done here adaptation so that his hands and his fingers are well supported. Something specific to the case of Hendrik, you cannot see quite well. He has a little box here. That's a multi-switch, and that's a box that you can plug one input into, so the one button that he's using, and you can connect it to 4 different outputs. So with that one button, he can control 4 things. The first output is the on and off of his chair. The second output is the modes of his chair. The third is his hand warmer, and with the fourth, he is controlling something on his smartphone. So you can really limit the setup and allow the person to control everything that he needs to by using these 2 devices. When the preferred anatomical site isn't the hand or the fingers, that's where you will really need some additional hardware. If it's the foot, you will need to mount it on the foot plate, maybe drill some holes in it, weld an additional bracket. If it's a head control, then you will also need, the head control will probably come with mounts from the manufacturers, but there are also others like Stelz Products, for example, who have a whole range of mounting equipment to do that. If it's the chin, there are also several options. We have an example here of someone who is using a harness with a multi-joystick on it, which is 50 grams of force and a travel of 8 millimeters. The benefit of the harness is that it is moving along with the user during the day as they are changing position. And it's also very easy to take the joystick off and the person is eating. You can just park it away. So you cannot see it if the person is not using it. Quite a discreet solution. Another option for a chin control is a motorized or a manual swing away arm or chin boom. And we have Patricia here who will be sideways, but she has MS and she's using an all-round joystick mounted on the swing away arm with 2 buttons integrated in the housing. So this housing has 2 slots that you can take out, and you can slide the buttons in so that you have easy access with your chin to the buttons and to the control of your chair. She manages to do that quite well. She also has a 3rd button on the side of her head that she can control. And these arms can be installed to move away either horizontally or vertically, whatever the user prefers. You want as little movement of the arm as possible. That's really the challenge. The installation of the arm is key here. If it's trembling, it will be difficult to drive. The advantage of this is that she can swing it away independently. The harness, the person will have to ask someone to remove it for them. And these types of arms are also sometimes programmable. For instance, with the additional button that she has, you can program a triple action under that, so that with limited buttons, she can do many more things. Yeah, that's our swing away arm, but there are other options available, of course. Next in our assessment process is operation. We place it after approach, but in reality, it's something that you'll do simultaneously. You assess the strength that the user has to move the control. And there are solutions available all the way down from 5 grams of force for people with severe muscular dystrophies, for instance, spinal muscular atrophy, all the way up to heavy-duty solutions for people with severe spasticity, solutions of 650 grams of force. So Sophie, the girl I mentioned earlier with her YouTube channel that you should check out, has tried to compare these types of joysticks to fruits. And I thought it was a funny way of looking at it. So for each type, she has selected the fruits. So the 5-gram joystick is a raspberry, the standard joystick is a grapefruit, and the heavy-duty one is a coconut. So if you would place the joystick in a horizontal position and you would put the weight of the fruit on it, the joystick would deflect and the wheelchair would start to drive. So it's a good way of visualizing the big difference between all the solutions. So as we said in the beginning, you have the sensitive joystick, standard, heavy duty, but not all people know what's in between. So even in the range of what we call sensitive joysticks, there are several options in between. So the standard one has 250 grams of force, that's the grapefruit. Then we can go to half of it, 120 grams of force, that's an apple. We call that the all-around light. Then we have 50 grams of force, that's the multi-joystick that was on the harness that we saw. The micro joystick, also available not only from MOWIS, also from other companies, that's grapes. And then we can do a modification of the micro joystick. Actually, we had a guy with Duchenne, a guy from the UK, who contacted us that he couldn't drive with the micro joystick anymore, with the 8 grams. And he asked us, can you do something? Can you help me? And we tried to do it. We could go as low as 5 grams. So that's something that we can do. But this comes, of course, with a set of limitations. We are really reaching the boundaries of what's possible there. You cannot put the joystick in a high angle because it's possible that it could start to drive by itself. You cannot put any other toppers on it because of the weight. And it's also good to guard it from environmental things as well. If we go back to the man who was using a joystick that required 50 grams of force, this is important for his chin control. 50 grams of force is really different than 120 or 250. And also the travel is important. It's 8 millimeters, so you have quite a bit of movement. With a more sensitive joystick, it would be difficult to do that. It's also good because you reduce the risk of repetitive stress injuries if the weight is, it's not too sensitive, if it's 50 grams instead of 250, for example. So let's go back to the example of Steven. So Steven started with this joystick, standard hand joystick integrated in his tray, 250 grams of force, and they installed the micro joystick. Is it the best control for him? It's difficult to say, as you have to take several things into account. On the one hand, you can say that it's a pity that they have not tried the 50 grams or the 120 grams, as he will very quickly get used to the low force and he will not train himself anymore for higher force. However, function and mobility should always be the most important thing when considering a new control, and the training, he can do that in another way. It's also important to introduce new methods early on so that he can get proficient in it and reduce potential frustration that he would get along the way. So it's a fine line that you have to walk. But at the end of the day, you have to think about the purpose. And his purpose was to be able to drive again, especially going outdoors. And he can do that now with the micro joystick that they have installed. So that's a major win for him, of course. Besides the strength required for the joystick, there's also some additional programming that you can do to make it easier for the user. There are parameters that you can set in the electronics of the wheelchair itself, but some manufacturers also allow for specific parameters in the controls themselves. And underutilization of these features has been described as one of the biggest obstacles to harnessing the potential of joystick technology. In the wheelchair itself, you can set tremor dampening, for instance. This is related to how quickly the wheelchair will react to an action that you do. Higher values of tremor dampening, however, reduce they reduce the effect of the hand tremors, but it will also increase the braking distance that you need. So maybe you could also try to increase the deadband, which will probably have the same effect, but it will not increase your braking speed. Another thing that you can do is try to increase the throw. The throw is how far, so I'm speaking about 20 millimeters. So that's the throw, that's the maximum throw. But you can also say that you will achieve full speed at a smaller percentage of that. So I have an example here of the link system where this parameter is, look at that, it's a straight video. Where this parameter is called joystick shaping. So you can see that you can have a different value for each of the directions. And it can be adjusted individually in each direction of movement. So when you're using a foot control, for instance, and it's more difficult to do the inside movement, then you can adjust it there. So you can read the highest speed, even if you have a smaller movement at one side than at the other. Using shorter distances to achieve the same level of speed, that requires a greater amount of motor control. So that's something that you have to take into account when you are adjusting this. We have talked about trying to avoid to have many buttons, and this is also a parameter that links into that. It's remote selection. So you can see that we have set a standby time of 10 seconds. And in the forward movement, we have selected a remote selection parameter. It will probably be, yeah, like that. But after 10 seconds of inactivity, so I will turn the wheelchair on with the on-off button. I'm using a foot control, and after 10 seconds, it will go into standby. And then, yeah, and when I'm moving my foot in this position, I can go through all the different functions of the wheelchair. So you have avoided another button this way. You can do a whole other stuff in reverse, left, right. You can have mouse emulation under these things, for instance, but you have to make sure that it doesn't get too complex for the user. So don't try to do it all at once. Changing the axis is another thing that you can do. So in the beginning, I said you need 180 degrees of movement. It's possible that you want to swap the axis if someone has a good control in one direction. You can also make the joystick into a three-way proportional joystick. So I turn the wheelchair on. My forward movement is going forward. Then I press the button. So now I'm going forward, press the button, my forward movement is going backwards. So that's also something that you can program to make sure that the user can still use it, even though he doesn't have good movement in all directions. Some manufacturers of special controls also have additional programming that they can do in the joystick, sometimes in their own programming software. And one example of this is the road compensation. And this is a parameter that's especially interesting when a joystick is integrated in a tray or when it's on an arm, for instance, where tremblements can be multiplied. Now it's time for a short commercial break by the city of Bruges in Belgium. Yeah, this is a city where I grew up. It's a very old city in Belgium. The oldest church, I believe, is from 1150. So if you're ever in Belgium, come visit. But it's also a city with a lot of cobblestones. So can you imagine driving with a power wheelchair with a chin control on these cobblestones? It's very difficult or even impossible to do. So I have a video here. I hope that's not...
People have difficulties to maintain the control of the wheelchair when they are driving in an outdoor environment with uneven roads. If you are driving there without a road compensation, it is not easy to control your chair. You have to adjust your position the entire time, and you are certainly not stable. This makes it difficult and sometimes even unsafe.
Bruges in Belgium.
Someone who is using a joystick integrated in a tray, he can continue to keep his joystick at maximum without losing control. This will stabilize the position of his fingers as well as his global position through the creation of muscle chains. When he reaches a better surface, the wheelchair will speed up again.
I don't know if there are any questions about this or not. The road compensation. So it's by default in our joysticks, it's not on, but it's something that you can turn on. For RNet, you can even say that you want it on in profile 1, that you don't want it on in profile 2, and that you want to do it manually in profile 3, for instance. Yeah, there's an accelerometer inside the joystick, and when it vibrates, it sends a signal to the wheelchair to slow down to predefined speed. So like I mentioned earlier, endurance is also an important element. It is possible that people do not have the endurance to control the wheelchair the entire day, or repeat an action several times with the same control. The initial strength can go away during the day, and fatigue can occur. Not only physical fatigue, but also mental fatigue or related to poor positioning. A lower force joystick can be a solution then, but also latch driving can be a help. It's most often used with sip and puff. So you give an input and you keep on driving until you give the next input. But if it's not done correctly, it can be a dangerous feature, so also should be used wisely to that one. However, sometimes it's not just fatigue, but tasks are too difficult for the user to do. It's difficult to maneuver through a narrow doorway, or going on long walks can be difficult. So then it can be interesting to have an attendant control on the back so that people can take over control. So this is Joshua, a boy from the UK who has cerebral palsy, and he has a single head switch here that he uses as a scanner control, but his parents need to take over several times during the day. And traditionally, a hand joystick or the normal joystick of the wheelchair is mounted on the back of the wheelchair, but that's not always ergonomic for the user. So it can also be good to think about other solutions there that are more intuitive to use for the attendant. Everyone has learned things in their lives that weren't easy from the get-go. And as a parent, you also see your child learning things, and it's not always easy. So this is my 4-year-old daughter. She's rolling her skates for the very first time. There isn't much rolling yet, and she makes mistakes. She will most likely crash into something. I have even had to tape her skate together. So it might be too early for her. And if I could avoid these stressful situations, that would be great. So navigating a power wheelchair can be daunting. And I imagine for parents with a child driving a power wheelchair, you're very scared. I remember a time with Movis, we have been helping with some children in school who were doing physical activities, and there was a boy and he kept going really fast and he tried to stop just before the wall. It was really scary, but yeah, they love to do it. So other things that you can help with learning where you can avoid these real life situations can be VR. This is a VR system of stealth, for example, where you can just drive in a virtual environment. You're in it, you see yourself sitting in a wheelchair, and you can do several tasks like driving in an apartment, trying to go into a room. You have to overcome some cyber sickness, maybe. We have several people who tried it. Some can do it without a problem, and some get really sick. So there are other commercial solutions available as well that are quite cost effective to do that. Another option can be adaptive gaming, for instance, a joystick, the same joystick that you use for driving, but with a USB port, for example. So you can try at first, can I control this joystick without having a very stressful situation? So we have an example here of Corneel, a Dutch man who has Duchenne, who is playing a video game with a micro joystick, but then not a micro joystick to drive, but a micro joystick to work on his computer or to play games, with an adapted handle and one switch. A more standardized way to train is, of course, the wheelchair skills program that I mentioned at the beginning. So the goals that you have set in the beginning should be monitored and revised again during the training. The training has to be specific. If the user wants to improve his ability in a specific task, that this task should be practiced. If the user wants to be able to use his new control in different settings, then these settings should be used, or even different chairs, these things should be trained. In many cases, it will also be the intention to be able to use the skill in a variety of settings. So you should go outside if that's what they want to be able to do. You also should practice in different states early in the day when they're still very active, or when they're more fatigued, to see if they can do it like that as well. You also should try to avoid interference. If you have decided, okay, this is the task that I want to learn, do that, and don't try to do it all at once. Be focused on that. And as to how much you should train, no one can really say, but for motor skills to learn well, there should be some repetition. So it's better to do small repetitions than to go hours at once, and certainly stop when they get bored or lose focus. Another tool that you can use is the ALP tool, the Assessment of Learning Powered Mobility Use. It's a tool that was developed by Nielsen and Durkin, and they have distinguished several stages in the learning process: an introvert stage, transition stage, and extrovert stage. And each stage has its own subdivisions. I have them here for the first stage. So you start at novice, then you go to curious novice, and then to beginner. And yeah, if we have the example here of beginner, they have distinguished some things about attention, activity, and movement that can help you decide in which stage they are in and which activities link into that stage, what that you can expect of them in that stage. It can be good to decide the stage they are in and then adjust your activities to that. So it's important that you have the right challenges, not too difficult because they can get afraid, or not too easy because they will get bored. It's also good if you say, okay, now you're in the curious novice stage and you train, you have several repetitions, and then you can see that they are going through the different stages. So you note that they are learning, and you can plot that, the progress, and continue like that. And then finally, we come to the point where you want to measure your outcomes. We go back to the very beginning when we have set out our purpose. What were our goals? And these goals should be measured and maybe revised as the training progresses. You can check out your progress with a goal attainment scale of the WSP. And for each skill or a part of the skill or anything that you have set in the beginning as purpose, you can give a score going from extremely poorly to extremely well. And you can combine that score to have a goal attainment scale. And you can, as training progresses, you can see if that gets better or not. Besides that, there are other possible outcome measures, such as you could see over a period of 6 months, if there's an increased injury rate, for instance, or in other words, injuries that were serious enough that medical attention was needed. You can also just have interviews with them, question the confidence in their wheelchair use. Or you can also look at mobility-related participation. There's also a tool, life space assessment. It was initially developed to be used by older people, but it can be used by people with who are driving in wheelchairs as well, to see if they are going just in their own environment, if they're going a little bit besides that, just to see how active they are with the new control. And then to finish, we have an example here of Nurgul. She's a Belgian girl who has cerebral palsy, and her therapist started to search for a new control, not because she couldn't control her existing control, which was a standard joystick here that was mounted underneath a tray that she was using as a foot control. But the worry of her therapist was that she was starting to develop back complaints. The height of the old foot control gives her a very asymmetrical sitting position, and it's not possible to place it lower as it would touch the ground. So we have replaced it with a dedicated foot control, which is lower. It's only 6 centimeters and isn't touching the height in the floor in her preferred position. You also see that it's not, in both cases, it's not positioned at a traditional foot plate, but they have welded an additional bracket to her chair. She has 2 buttons on her knees, positions for access. And normally she also has a positioning vest on to strap her to her chair. And because she cannot really see her feet, right? So we have talked about that. She doesn't feel really safe, and she wants a bracket around her feet at all times so that she knows that she will not damage anything in her environment. She is doing one of the skills here of the WSP, which is driving backwards with her old control. This is her old control. And you can see that she doesn't have a problem driving. That was not the issue of the new control. And with the new control, you will see that it's more difficult now. In the beginning, it's also the first time. So she will need some learning. She will have to get used to the new control. But her real goal is to get rid of the back pain. So that is really the outcome that needs to be measured here. And in her case, the therapist concluded that the new control was really beneficial to her seating position. So that's what they went with. And with that, we have done the full circle from purpose, cognition, approach, operation to learning, and we have measured the outcomes. So I hope that I am giving you some inspiration for today and that it was more interesting than the basketball game outside. And I want to know if there are any questions.
Thank you.